Hello friends, welcome back once again to this series of learning design and analysis of algorithms problems. So in this session we'll move to the next experiment, that is print all the nodes reachable from a given starting node in a given diagram using Bfs method. That we have to solve in this session, and we have to understand how this Bfs method is useful for solving problems of diagrams. So here we have to understand first what is Bfs method, what is the technique we are using to solve this particular problem, and we have to write, once we understand the problem definition, we have to write the code for this. So let me brief you about Bfs. That is breadth first search algorithm. It is an breadth first search algorithm that is used to graph data or searching tree or traversing structure. The full form of Bfs is, that is breadth first search. The algorithm efficiently visits and marks all the key nodes in a graph in an accurate breadth-wise fashion. So this algorithm selects a single node, that is initial or source point, and in a graph, and then visits all the nodes adjacent to the selected node. And you have to remember that Bfs accesses these nodes one by one. Then once the algorithm visits and marks the starting node, then it moves towards the nearest unvisited nodes and analyzes them. So once visited, all nodes are marked. Then these iterations continue until all the nodes of the graph have been successfully visited and marked. And you may ask, how does Bfs algorithm work, right? So the graph traversal requires the algorithm to visit, check, and update every single unvisited node in a tree like structure. Then graph traversal are categorized by the order in which they visited the nodes on the graph. Bfs algorithm starts the operation from the first or starting node in a graph and traverses it thoroughly, and once it successfully traverses the initial node, then the next non-traversed vertex in the graph is visited and marked. Hence you can say that all the nodes adjacent to the current vertex are visited and traversed in the first iteration. So a simple queue methodology is utilized to implement the working of a Bfs algorithm, and it will be, as an example I'm going to consider here, it will be considering n number of steps for that. So here I'm going to consider an example. So I would like to draw that a diagram here. So just a minute, I'll draw that particular diagram and I'll show you that how it works and what are the steps it will be taking. So this is how the diagram looks like as an example for this Bfs, that is breadth first search. So this is also the architecture of Bfs algorithm. So initially we have to mark any node as starter or initial, that is the level 1, that is level 0. Then after that we have to explore and traverse unvisited nodes adjacent to starting node. That is, if you have selected here a as the starting node, then which all are the nodes which are adjacent to this node A, they are B, C and D. These are the adjacent nodes. So we have to traverse from A to B, then B to C, C to D, something like that. We have to explore and traverse all the unvisited nodes which are adjacent to the starting node. then that is level 1. And after that, what we have to do here is we have to mark each node as completed and move next adjacent and unvisited nodes till it will be continuing till the completion of all the adjacent nodes of those starting nodes. And after marking the visited nodes, then we have to select the next visited node. Again, we have to find the adjacent nodes of that visited node. This process will be continued until the completion of all the adjacent nodes, until marking all the nodes which are nodes like which are visited. So this is how the diagram looks like as an example, that is BFS, that is breadth first search algorithm. So that is all about the introduction part of and working of breadth first search algorithm, and we have to make use of that algorithm here in our program, and we have to code for that. So I'm going to consider here one method, that is one function, that is BFS, and it is taking arguments like an two-dimensional array, then an integer variable, then again one-dimensional array and another integer variable. So this is a globally declared function I'm going to use in my main method. So in the main method, what I have to do here is, so the return type of main method is void then I'm going to consider here some variables like n, then a of 20, that is two-dimensional array, comma I comma j, then visited as an array here, that is all the visited nodes I'm going to store in this array, then source. Then once we are ready with the variables which are going to use in the program, we have to ask the user that printf enter the number of vertices, enter the number of vertices. Then read that with the help of scanf statement. For that, scanf %d, then comma ampersand n. It will be reading the location or address of variable n from the memory, and it will be storing value that whatever the user enters here. So after that, what we have to do here, we have to ask the user to enter the adjacency matrix, printf, then enter the adjacency matrix. Adjacency matrix for the graph. So how to read that, right? With the help of for loop, we have to read all the elements of the adjacency matrix. So for I equal to 0, I equal to 1, comma I less than or equal to n, then I plus plus. So one more for loop, that is j. So for j equal to 1, then j less than or equal to n, and then j plus plus. Then with the help of scanf statement we have to read them in and store them in the two-dimensional array, that is a percentage d comma address of a of I and then j. This is how we are going to read all the elements of the adjacency matrix. Then we have here for loop for store all the visited nodes, that is for I equal to 1, I equal to 1, I less than or equal to n, then I plus plus. So here visited equal to visited of I is equal to initially 0. Then we have to ask the user enter the source node. So for that we have to use printf here, printf percentage d slash n, then enter the source node. This will be the starting point of the traversal of the digraph using Bfs algorithm. So once you entered the starting node, then we have to read that with the help of scanf statement. Scanf percentage d, then address of source. This is the variable I'm making use of it, that is source. Then so now visited will set to visited of I will set to 1. So now I have to call the Bfs method. So Bfs function Bfs of a is the name of the array, comma source, which is the source node. Then we have visited, which all are the visited nodes. Then n, number of nodes. So n number of nodes we have to visit, and we have to read source node and the array of the adjacency matrix. So then for that what we have to do here is we have to make use of a for loop for I equal to 1 less than or equal to n, then I plus plus. So after that what we have to do here is, so if visited, we have to verify that whether that particular node is visited or not. If visited of I not equal to 0, then printf slash n node percentage d is reachable. That is I. We are going to print that particular node which is reachable from the source node. That is or else what we have to print here is else printf printf /n, then node %d is not reachable, is not reachable. That which node is not reachable from the source node, that we are going to print here with the help of this printf statement. So this is all the main of my main method. So we have to write the Bfs, the body of the Bfs function here, that is, so void, the return type of that Bfs function is void, then it is going to take an array as an argument, that is two-dimensional array. So max size will be become 20, then int source, then int visited of 20, then int n, that is the number of nodes. So here we have to maintain a queue, int q equal to int q of 20 size of this array, then f comma u comma v comma r, f u v r. Okay, these are the variables I'm going to consider here for this particular function, that is Bfs. Initially f equal to 0, then r equal to 1, q, that is array q plus plus r equal to source, we are going to initialize. Then after that we have to check one condition here, while f less than or equal to r. Then what we have to do here is we have to set u equal to q, and we have to increment it with the help of f plus plus. Then for v equal to 1, then v less than or equal to n, then v plus plus. Then if a of u, then v equal to 1, and visited of v is equal to 0, then what we have to do, we have to perform these operations such as q plus plus r equal to v. Then we have to set visited, we have to assign the visited nodes to 1, that is visited v of v equal to 1. So this is all about this Bfs function, and we are going to make use of this Bfs function in our program. So let me run this code and check whether it gives the proper output or not. So click on the run button here. There is an error, visited undeclared. So click on line number 22, visited that is visited. Then again click on the run button. Still there is an error, so click on the number 30 it is. So there is a semicolon missing, so click on run button once again. Still there is an error. Okay, line number 30, for I equal to 1, I less than or equal to n I plus plus. So click on the run button again. Yes, it is working. So enter the number of vertices. So we have to enter here number of vertices. As an example, I'm taking 5. Then enter the adjacency matrix. So for that, so 0, 1, 0, then 1, 0. This is my first row. Then in second row, 0, 0, 1, 0, 0, 0, 1, 0. So here 0, 0, 1, 0. This is my second row. That is from node 1 to 1 is 0, 0 direction, 0 edges are connected. Then 1 to 2 is that is 1, there is an edge which is connected to 1 to 2, and 1 to 3 is there is no edge. 1 to 4 is there, 1 to 5 is not there. Again 2 to 2 is 0, 2 to 1 is 0, then 2 to 2 is connected, then 2 to 3 is 0, 2 to 4 is 0, that is 2 to 5 is 0. Then in third row, because I have entered the number of vertices is 5, so I have to enter 5 rows, 5 columns for the adjacency matrix. So next row is 0, 0, so here 0, 0, 0, then 1, then 0. This is my third row. Then all zeros. And then last row, that is 0, 1, 0, 0, 0. So this is my adjacency matrix. So then hit the button enter. There is a mistake, so run it once again, because I have entered here one more element, that is one more element to this adjacency matrix extra. So click on run once again. So enter the number of vertices 5, then enter the adjacency matrix, that is 0, 1, 0, 1, 0. The next row 0, 0, 1, 0, 0. So then third row is 0, 0, 0. Then we have 1, 0. One, 0. Then fourth row is 0, 0, 0, all zeros. Then the fifth row is 0, 1, 0, 0, 0. So this is my adjacency matrix, then enter the source node. So I'll enter here 1 is my source node. So segmentation fault, still there is an error, so I have to check the code. So run it once again, click on the run button, then check whether it gives proper output or not. So 5 number of vertices, then enter the adjacency matrix, that is 0 1 0 1 0, then we have 0 0 0 1 0 0, then we have next 0 0 0, then 1 0, then we have 0 0 0 0, then next we have 0 1 0 0 0. This is my adjacency matrix. So click on the button, enter the source node. So I'll enter 1 here, then it is giving output as, that is, after entering the source node as 1, the node 1 is reachable, node 2 is reachable, node 3 is reachable, and node 4 is reachable, and node 5 is not reachable. So this is how we can verify whether all the nodes are reachable from the source node or not from the given adjacency matrix. So with the help of given adjacency matrix, we can draw the graphs, that is diagrams, directed cyclic graphs. So this is how the Bfs algorithm works to find whether there is a path or there is a route available to visit all the nodes from the source. So this is all about this session. If you are having any doubts in this, please do ask your queries. Definitely I'll be helping for your queries. Definitely I'll be solving your doubts. So please do watch this, and if you are having any doubts, you can ask your queries. And thanks for watching.